All right, Rohan, I think we can get started.
Hello, we're Team 16725, also known as Leobots, and today we'll be exploring OnBotJava, as well as providing an introduction to Java programming, and then looking at some examples of teleop and autonomous code. Java programming is an essential part in FTC. FTC contains two parts: the actual physical robot where you build the parts and the mechanics, but then there's also Java programming, which allows the robot to move in different directions, speeds, and allows it to complete the tasks using Java programming code. Why OnBotJava? OnBotJava is an IDE commonly used for programming FTC robots. Although there are other IDEs where Java programming is used, the methods and templates that are most related to FTC robotics is on OnBotJava. It's also ease of synchronization with apps on phones, and this is especially important in FTC where you can synchronize your code to a phone and you put that phone on a robot, so then that robot can run without having a wired connection to your computer, so it allows wireless access and ease of code transmission. So it's also accessible from multiple computers, so it allows for asynchronous activity without having to work on one specific device. What is Java? Java is a fast, secure, and reliable, as well as one of the most popular programming languages. However, Java and FTC is used for programming autonomous and teleop operations. It is the code that allows you to complete specific tasks and allow the robot to move in autonomous and complete those tasks. The one IDE we use is OnBotJava, but there's also Android Studio, which is a more advanced version of OnBotJava. So Java programming and many other programming languages have two components, syntax and logic. An analogy for this would be like syntax would be grammar rules, such as like periods, commas, semicolons, and logic would be applying those rules to complete a task, such as creating paragraphs or sentences or an essay. So syntax in code is the actual characters that are the commands and allows you to produce an output. One of the most famous ones is system.out.println hello. So those characters and those rules, such as a semicolon at the end, allow you to print that output. And then using all those rules, you create a series of steps, which is a logic component. This is like the mentor thinking aspect, where you think of what steps you need in order to complete the task. The logic component can be simplified into 7 steps: identifying the problem, chunking it into manageable parts, designing a plan for each component, implementing a plan, testing a plan, combining it into one program and testing the whole program. Identifying the problem is one of the most important ones. Knowing the basic steps and brainstorming can guide you into the correct direction. And then chunking requirements into manageable parts. This is not only for programming, but this could be applied to any problem. Approaching it all at once directs your focus into too many directions, which is not the best way and the most efficient. So chunking it allows you to focus on one specific aspect at a time. And then designing a plan for each component. Before you dive into the code, knowing what tasks you need to complete and what to move and where your robot should go makes it much easier. And then you can implement your plan, which is the actual coding part of the robot. And then you can test it. Testing is important because although you might think of something in your head, it might not directly translate into code, and testing it validates that. And this also relates back to number 2. If you test each component and instead of writing a whole section of code and testing it, testing each specific code allows you to solve problems quicker. If you know that that section of code contains a problem, then you can solve it much faster. And then once you've coded each part and tested it, you can combine it into one whole program. But even that doesn't guarantee fully that your program works. So you have to test it and make sure it works consistently. And then once you have that, then you know that you're successful. Now I'll hand it off to Kedar to talk about what lessons we're going to teach in Java today.
So just for a minute before I head into the main part of the class here, I just want to explain like an example for the 7-step process that Rohan just explained and how you can use OnBotJava for that. So say you want to code your robot to pick up a block, right? So that requires a lot of different steps to pick up that block. You need your robot to move forward, you need your arm to lean down, then you need your arm to close around the block, and then you need your arm to again rise, and then your robot to move again. So that's the second step, realizing all of these different components. And then after that, you want to design a plan for each component. How is your arm going to come down? How fast do you want your robot to go? How far does it have to travel? This is especially important in autonomous. And then implementing the plan, this is where OnBotJava is, of course, incredibly important. Our goal here is to help you, give you the basic blocks, the foundational tools to code that part. And then testing. No matter how good of a coder you are, you will almost always have some bug in your code, and it will take you quite a bit of time to figure out where it's coming from. And even after you put in all of your individual wheels and the arm, combining them together usually results in another bug as well. So testing all of them together will always take quite a bit of time. Now, for the main part of the class, today we want to give you an introduction to classes, variables, conditions, loops, and methods, and how they can help you code for FTC and OnBotJava. So classes are where you're going to be doing the actual coding itself. They're the blueprint in the IDE. In OnBotJava, you usually won't need too many classes. You usually have one that's the teleop. That's where you control the robot with a controller, and then the autonomous. So you might sometimes have to import or extend classes in Java. It's not too common, but when coding for FTC, as you'll see in the example on the next slide, you may have to do it at certain times. So in this part, you're seeing the teleop extends linear op mode. Now, linear op mode is usually the most common op mode used for Java, and it's usually used because there are some basic methods that can help you create coding your robot to run. Now, variables. So variables store a value. Usually in Java, they have the capacity to hold integers, doubles, booleans, characters, and strings. So integers are just your basic whole numbers. Doubles are then those numbers but with decimal points. Booleans are true and false. Characters are just singular letters, and strings are phrases. Usually, the only ones you're going to be really using in OnBotJava are integers, because you want to hold values like, for example, the amount of power you want a motor to have. Or you might assign the position for different parts of a robot number values. So obviously in math, you would variables usually just have letter names, X, Y, W. But in Java, you always want to make sure to give your variables the most descriptive names you can, because especially for FTC, you're going to have a lot of them and you do not want to mix them up. So in this one, as an example of what I said earlier, this double motor power right now, we're just initializing it. So it's only going to have 0. We've declared it as double motor power, so it's a double, and we've initialized it as 0. Now later, we'll see, you can change that value and modify it. But right now, just so it exists, we're defining it as 0. Now, for conditionals. So these are statements whose code only runs if a certain condition is true. As a result, they're also known as if statements or if-else statements. So, for example, in FTC, for example, you might use this even more in the teleop mode where you're controlling the robot. For example, if this button is pressed, then you want the robot to move forward. If this button is pressed, you want the arm to move. If this button is pressed, you want it to move backwards. You can actually see that right here. For example, if gamepad1.x arm.set position here, if you press another button, you maybe only want it to turn it halfway. And then if you press another button, you want it to move that full 180 degrees. Now, loops are also very commonly used in OnBotJava for FTC. So there's two kinds of main kinds of loops, although one is used far more commonly than the other, as far as we've seen. So you have while loops and you have for loops. Now, while loops run until something happens. So for example, you could have, just a general example, you could have while x is greater than 3, do this. And for example, x could equal 5, and each iteration you do, for example, x minus 1. So that while loop would only run for maybe 2 runs, when x is 5 and then when x is 4, and it would stop. Now, obviously, for FTC, we're going to be doing something a bit different with while loops. Now, for for loops, these aren't usually used as common, but for example, it would be something like for and then parentheses, if the variable equals this value and it's increasing by this iteration, we wanted it to run until it reaches this value. Now, usually these aren't used as commonly in FTC. Usually we use while loops more. So as you can see here, the most common use of a while loop that you'll probably have in OnBotJava for FTC is while the op mode is active. And so basically what this does is, as long as you press the on button on your robot, for as long as that button is on, this is the code that'll happen. And then the minute you press the off button, this code will no longer run. Methods are probably the most important thing you can learn in all of Java. They combine everything you've learned together before and put it all together. So they're almost basically mini programs that you can run. They're individual programs, and there's several different kinds of methods that you can have. You can have private methods. These are methods that you can only use in your class. You have protected methods. These are only methods that you can use in your package. And then you have public methods. These are methods you can use anywhere. Now, for example, what exactly is a method? I'll explain in a second. But the other thing, distinguishing part of methods are they void or do they return a value? For example, you could have a method like add number, and the method could have add number and then parentheses x. And then whatever the number x that you input, it could add x to another number. And so it could return that number. Usually in FTC, you're not going to return anything. The methods are more likely to instead perform some kind of action using the variables you input. Now methods are like variables in that if you want to return a variable, you can have them be an int, double, boolean, or character. So for example, looking at this method, it's taking in the right power of the right motor, the left power of the left motor, and then the amount of time you want, for example, the robot to pause after it executes that action. Now, as you'll notice, this is a public void method. So we could use this method in any class we want, and this method isn't going to return anything. It's just really doing something. So it'll take in that right power, it'll take in that left power, and then it'll right drive, as in, of course, the drive of your right motor, and the left drive, the drive of your left motor. It will execute that action, and then it'll slowly pause for a certain amount of time.
All right, so far we discussed these things in theory. Now we will actually take a look at some sample teleop and autonomous code to go over how to apply this in practice. So as you can see here, this isn't OnBotJava, but because we don't have our phones on us right now, but this is an online Java compiler. And if you took the code I have right here and pasted it into OnBotJava, it would work. So starting off with the first line of code, we have the package, which is a specific package. As you can see, the first inspires an FTC team code package. So the reason you put all of your classes inside of this package is because there are certain classes in this package that you have to extend, such as the linear op mode class. And basically these contain methods and functions that are specific to OnBotJava, and I'll be going over some of those as we get deeper into this code. So the next line of code you have are these import statements. The first import statement essentially tells you that you are getting specific functions for the teleop section of your code. This is specifically because we have a DC motor, which is, your standard motor in this code, and we're coding for a motor. This is a servo, and this is the linear op mode class that we're extending over here. So you might be asking yourself, why are we extending this linear op mode class? What would happen if I just deleted this statement? The reason you can't just delete that statement is because if you were per se looking at one of these lines of code, such as the hardware map.get, that isn't necessarily a standard function in Java, and you can't really call that method. However, the linear op mode class defines these kinds of methods. That's why you need to extend it so you can use them. Here we are declaring our moving parts of our robot. So these are the two DC motors, and they symbolize the right drive and the left drive. So if we were to think of a robot where the right side of its wheels were controlled by this motor, and then the left side of its wheels were controlled by this motor, that's essentially what we're symbolizing with this code. And then we also added in a servo just in case you wanted to grab something, and that we symbolize as the arm. So here is where you actually get into the code that will run whenever you're executing. So as you can see, you have the run op mode method. Kadar referenced this earlier, and that comes into play when you have the while op mode is active. Essentially what this does is whenever you have the start button and the stop button on your phones, that's when you're running the op mode. So using this method, make sure that your robot isn't running when it isn't supposed to. Because, for example, if your robot doesn't start on start and stop on stop, that could be a serious violation in many FTC matches. That's why you need this method. Now, moving on, this is where we actually get our motors. So up here, we declared the right drive, and now we're actually going to assign that to the physical motor we have. That's the hardware map.get method. What that does is whenever you connect your motors to the Rev expansion hub, you can name them. And using that name, you can actually map them and assign them to a variable in your OnBotJava code. Again, we do the same thing with the left drive and also with the arm. So here you can see this is one of the specific methods I was talking about, wait for start. So this line of code makes sure that your robot's not running unless it's in the start mode. Now, here you see some telemetry statements. These aren't actually mandatory per se, or they play no part in actually moving your robot. But what telemetry does is it provides you feedback, letting you know where your robot is. For example, this statement would display on your driver's station phone. It would tell you that your code is executing. And here you use the update statement so that that actually pops up on your phones. Now, we referenced while loops earlier in the presentation, and we specifically talked about the while op mode is active loop. Again, this goes into play with the wait for start and also the run op mode. This makes sure that your robot's always running when the op mode is active. Now, the variable types we talked about, the two main variable types you're really going to use in OnBotJava programming is integers and doubles. The difference between an integer and a double is that an integer can only store whole numbers, such as 1, 2. You could also store negatives, -1, -2. However, if you wanted to store a value like 0.5, you wouldn't be able to do that in an integer. That's why you have doubles. Doubles are essentially the same thing as decimals. They allow you to store 0.5, 0.7, these kinds of decimal numbers. So here we declared power to 0, and in the next line, we are setting power to the right stick Y on your gamepad. Again, this is where we have to make the conceptual connection between the code and the actual controller. So if you can visualize the controller in your mind, you could see that the right stick, whenever you go up on the right stick, your power will increase. You might be wondering why I multiplied this by -1. There's an interesting aspect with the Logitech controllers where actually if you move up on the controller, it actually comes as a negative value. So what I'm doing here is just changing that into a positive value so it's more intuitive to the mind, so that when I'm actually pressing up on the controller, my motor's moving up. So here we're taking our motors and setting them to the power, whatever it might be. It's going to be a number anywhere between -1 to 1. So a value of -1 for power would move your motors backwards at full speed, and a value of 1 would move your motors forward at full speed. Again, we have the telemetry statements. This time, what it's telling us is the motor power. So for example, if I didn't want to go full speed, I only wanted to go half speed, I wouldn't necessarily know that just by positioning myself on the controller. Instead of having to guess that value, this telemetry actually gives you feedback on what the exact motor power is. Now, this might not seem like a big deal, but when you're actually in the teleop section of the game, this kind of feedback from your phones can be the difference between successfully completing a task and utterly failing. So telemetry statements, though not essential to the code itself, are highly important once you get into the game. Here you have the if statements that we were referencing earlier. So if you pressed the X button on your controller, we would set the servo position to 0. Servos have a position anywhere between 0 and 1. 0 is essentially the same thing as 0 degrees. Your servo is straight. And 1 is the same thing as 180 degrees. So your servo would be flipped the other way around. When I press X, my servo comes into the straight position. Now, if I press B, my servo turns to the right 90 degrees. And then if I press A, my servo goes into the 180 degree position. The important thing to keep in mind here is that you're not actually incrementing the position. So some people might confuse themselves and think, if I press B and then press B again, I would have turned 180 degrees. That's not what happens. You actually set the position. So no matter how many times you press B, your servo will always go to the same position. That's why you have a set position. So it's important to keep in mind that you don't make the difference between incrementing by 90 degrees versus setting it to 90 degrees. Again, same thing here. You're setting your servo position to 180 degrees. You're not turning the servo by 180 degrees. And finally, we have the telemetry statements to tell you what your servo's position is. So that was a basic skeleton teleop code. You know, you could do some basic tasks with this, such as, driving or, navigating a servo. But if you wanted to get into more complex actions, you could just add on to this code. You could add more servos, more motors. You could also add more if statements. And there's really a lot you can do, but this basic skeleton code can work for really any team. Now, autonomous is a bit more complicated than teleop code. We have, again, the same thing. You have the package, as I explained. This gives you specific commands that you can use in OnBotJava. Now, the important thing to note here is that I added some import statements. So the new import statement you see here is I'm importing the autonomous class. Again, now we're in autonomous, not teleop. So technically, even if I deleted this line of code, that wouldn't change any of my actions. So I'll just go ahead and delete that. Now, I also added the elapsed time class. This isn't necessarily a vital function, but the elapsed time class gives you the sleep method, which I use in this code, sleep 1500 milliseconds. So what sleep does is that essentially in autonomous, you as drivers have no control. It's entirely up to the robot. You pre-program it. So there's two ways to go about getting your robot to move. You can either set encoder values or you can set specific times for it to move. Encoder values are more complicated to code. However, they are more accurate because the problem with sleeps is, say, for example, you have a full charged battery, your motors would be spinning much faster than if your battery dropped down to 50%. So 1500 milliseconds might move you 20 centimeters at full power, but only 10 centimeters at half power. Therefore, we are only using sleeps as a beginner element to really teach you the concept. However, we highly suggest that you look into encoders and use them for your autonomous code. Our first year, we used sleep codes initially, and we realized that it led to some inconsistencies. And once we switched over to encoders, it really helped us out quite a bit. Okay, so now getting into the actual code. You can see that yet again, I extend the linear op mode class. Again, there's some specific methods in there that I'll be using. So compared to the teleop code, the main difference you see here is obviously once you get lower down into the code, all of this code is the same as teleop. So you declare your motors and your servo, you use the run op mode, and then you get your hardware maps from the phones. And again, you have the telemetry statements to let you know that you're running the code. All right, so I'm at line 29 right now, and this is where we see the difference between autonomous and teleop. So in teleop, these are called keybinds. I was setting specific actions to happen whenever I press a key. But obviously in autonomous, you're not using a controller, so you're not going to use keybinds. Instead, you're going to set your motor powers to specific values. You dictate those values. So right now, what I'm doing is I've set my right motors to full power, and I've set my left motors to full power. So if we can visualize it right now, my robot is moving at full speed forward for 1500 milliseconds. You got to remember the units. This isn't seconds, it's milliseconds. So 1.5 seconds is how long I'm moving forward. After that, the change I've made is I've set the right motor power to -1. So now my left motors are going forward, but my right motors are going backwards. What happens when you do that is that you'll start to see that you turn to the right. So my robot is turning to the right for 500 milliseconds or half a second. Now, I am essentially reversing that. Now I'm turning to the left. Since my right motors are moving forward and my left motors are moving backward, I'll be turning to the left now. And that's for 500 milliseconds as well. So again, if we were to visualize it, our robot has moved forward, turned to the right, and then turned back to the left, so it's facing straight again. And now we'll move backwards for 1500 milliseconds. As you can see, right motors going backwards, left motors are also going backwards. So I've gone from my starting position, moved 1500 milliseconds up, turned right, turned back left, so then I was straight, and then I moved backwards back to my starting position. So my robot started and finished at the same place. Now, you might notice that this can get a bit tedious for autonomous code. You'll see that you'll have to perform much more complicated functions than just moving forward, turning, and then moving backwards. And already you can see that such simple code took up 15 lines of code, and it can be really difficult to sort through that. That is where methods come into play. Methods are vital to autonomous coding. So, two things to notice about this method. Number one, you could see that I came outside of my public void runoff mode method. You could see that everything in the runoff mode method is enclosed in there, and I'm declaring my new method outside of that. The important thing to remember is that you can never declare a method inside of another method. You always want to come out of your main method before you declare the new method. So I'm outside of my runoff mode method, and now I'm declaring it. Public void. So you might be asking yourself, what does public void mean? So public means that any class can access this method. That's not necessarily important for FTC, but essentially what it means is if I were to create another class in this same package, I could access the move method. Now void. Void is important. Void tells me that this method returns nothing. I don't get a integer, double, or string back from this method. It returns nothing. And here, for the first time, we are seeing parameters. Parameters are specific values we enter into methods ahead of time. So here we have a double, which is a decimal, and that tells us the power of the right motor. And we have another double, and that's the power of the left motor, and we have an integer for time. So that's just skeleton. I haven't necessarily declared these. I'll show you about actually calling methods that's up here, and we'll get into that later. So inside of the body of the method, what am I doing? I'm setting my right motors to right power. So I'm taking this variable and I've put that down here. So I'm setting my right motor power to right power, and I'm setting my left motor power to left power. And then my sleep is to time. So if you were really keen about observing what I did here, I essentially took these lines of code, which were kind of concrete. I had 1, 1, and then 1500. Those were concrete numbers. But instead of using concrete numbers, down here, I used variables. Variables, we can change them. So now to calling methods. As you can see, I named this method move. And if we go back into the runoff mode method, I start to call them. So move 1, 1, 1500. So what is this 1, 1, and 1500 doing? What I'm doing here is this: I'm assigning in order. I'm assigning right power to 1, left power to 1, and then time to 1500. So what that's going to do is that's going to move my robot forward for 1500 milliseconds. This line of code does the same thing as these 3 lines of code. So it really condenses your code down. And now, again, this is my right motor power, left motor power, and time. So now I'm turning right for 500 milliseconds. The same thing as these 3 lines of code. And here I'm turning left, same thing as these 3 lines of code. And here I'm going backward, same as these 3 lines of code. So by using methods, I've taken these 12 lines of code and condensed them down to 4 lines of code that I can change at any time I want. And that's why methods are extremely helpful. They allow you to use variables to create abstract concepts that you can declare in concrete. The worst thing you want as a coder is to declare set numeric values. What happens when you start to do that is that if you want to edit your code, you're going to find that you're going to spend a lot of time just copy and pasting or deleting and replacing numbers. But instead, if you use variables and methods, as long as you change the number at one place, you can change it for a vast amount of code. So let's say I don't want right power to, I want right power to be the same thing as left power. So I could just delete right power in my method and set this to left power. And if I go over here, now I only have 2 parameters, so I could just delete my first parameter. All right, so now what I've done is I've essentially set both of my motors to the same power. So both of them are going to be whatever I declare as left power. So you could see this would move my robot forward, these 2 statements, and then these 2 statements would move it backwards. Now, if I wanted to make that same kind of edit with this code, that would take a lot more time. I'd have to delete these statements, then change these numbers, and then keep deleting for all 4 lines of code. And that gets tedious just for 4 sets of blocks of code. And once you're writing 30-second autonomous codes, you'll find that you might go into 200 lines of code with like 10 blocks or 20 blocks, and changing all those numbers every time you have to make an edit can get really tedious and time consuming. That's why you want to use methods. So that concludes our actual presentation, and now we're going to open up the floor to Q&A. All right, so the first question is, what is the significance of the lines starting with the @ symbol? Okay, I'm sorry, I did not explain that part. So if you go back, I at 2 times in my code, I'll just share my screen again. So twice in my code, you could see @autonomous and then @override. So these lines of code aren't necessarily doing anything, but what they're doing is they're telling me that this is an autonomous program. And @override is generally something you write to restart your code. So even if I deleted the @override or @autonomous lines of code, it wouldn't make a major difference in how my program runs. However, what @override specifically ensures is that your robot resets itself to actually get into the runoff mode method. And in rare cases, you might encounter bugs if you don't include that line of code. So we suggest including it, but even if you deleted it, it wouldn't make a major difference. It's just for precautionary measures. All right, so the next question is, can you explain how to call in sensors? Okay, so again, the generic method for calling in anything is up here. So you can see you first have to import the class. So if I'm using DC motors, I have to use this import statement. Import com.qualcomm robot core hardware DC motor. Here we have the same thing, but instead of DC motor, I have servo. Now, if I wanted a sensor, you'd use the same thing yet again. Com.qualcomm.hardware. And then, all right. And for example, if it was a color sensor, leave the class name is actually color sensor. You're going to have to, sometimes if you just switch it up, you can get the class names, but I believe it is color sensor. And the second place where you're going to have to do this is at the hardware map. Oh, first of all, you got to create a variable for it. So private color sensor, and we'll just name it sense. All right. And once I come down here, sense equals, same process, hardware map.get. But instead of servo.class, you're going to use color sensor.class. And instead of arm servo, we are going to, well, the stuff inside of the quotes is not actually set in stone. It's whatever you name it whenever you're plugging it into the Rev expansion hub. So I could have named this a gazillion different things, but I just chose generic names. Let's say I named my sensor just color. So now I've officially assigned my color sensor to the sense variable. All right, so the next question is, for notebook purposes, would you screenshot pictures of the code with comments? I think Rohan could take that.
Yeah, you can use the screen clip app or something, and you can just screen clip it, and then you can paste it into a Google Doc or into your notebook, and then on that notebook you can add side comments or comments about the code.
All right, so the next question is, will we be able to access this video? I think Kadar could take.
So I believe this video will be accessible. I think it's being recorded right now, so I think you will be able to access this video later.
Yeah, so this entire video has been recorded, and you'll be able to find this YouTube. You'll be able to find this on YouTube in two places. You could see it on the Almond Robotics channel, and you'll also find it on our own channel, which is at sfleobots@gmail.com. So our channel is at sfleobots, and you'll be able to find it there as well as on the Almond Robotics channel. All right, so if there's any other questions, we'll answer those. Otherwise, we'll wrap it up for the day. Yes, so the next question is, would Mecanum wheels have different code than normal wheels? Yes, they actually would. So I think Kadar could expand upon that more.
So we didn't have quite the amount of time for me to really go into like the intricacies of how to code Mecanum wheels, but to make it more basic, for a normal wheels you have forward, backward, and you can turn. For Mecanum wheels you can do all that, but you also have the added benefit of horizontal movement. So the horizontal movement and then omnidirectional, so you can truly move it completely, makes it so that you have to utilize the diagonals of the wheels correctly. So the diagonals are opposing each other. So if you want to code Mecanum wheels properly, you have to keep that knowledge in mind. I don't have quite the time to go into it like fully, but mechanical wheels are especially what I was referring to earlier, in that you are most certainly going to have several bugs when coding them, and they're exactly the kind of wheels that you want to test again and again and again, because it requires knowledge of which diagonals, moving which diagonal will move which other diagonal, which will move the wheels as a whole.
Yes, so actually I'm pulling up a diagram right now that kind of expands upon Mecanum wheels a bit to better answer your question. All right, so this is actually one of the images we use to understand how Mecanum wheels move, and this actually does a pretty good job. So if you look at the picture here, how Mecanum wheels work is that they have essentially rolling pieces on them that face in certain directions. So this diagram kind of explains that well, and how they essentially form an X shape. So these two wheels, the front left and the back right, face to the right. So they are diagonally tilted to the right, whereas the front right and the back left are diagonally tilted to the left. So if you wanted your robot to move straight, you essentially just set all four of your motors to straight. If you wanted your robot to move to the right, you set these two, front left and back right, to forward, and then front right and back left to backwards. And diagonal is just these two. And if you want to turn, it's pretty much self-explanatory. And if you wanted to actually keep your robot in place while still moving your motors, which, you know, would, if you moved your front 2 wheels forward and your back 2 wheels backward, your robot would actually spin in place, which, you know, limited application, no real reason why you should do that, but just interesting fact. So this, if you just search up mechanum wheel movement, you'll get this image, and it explains it well how to move your motors in order to get certain movements. All right, then, if that's it, you know, that was a great opportunity to share this information with you all. We hope you enjoyed it, and thank you for watching us and bearing through some of the technical difficulties we had at the beginning. We apologize for that. Thank you.